We completed all the theory under the topic of friction last week, and I gave you, I think, 2 questions for homework, 3 questions for homework. So let's start by discussing those 3. I'll take up the textbook question first, page 107, number 16. Let me show you the question and let me know whether you got the answer to that. Okay, so it's a show question, which is nice. We like show questions because then we can check for ourselves whether we got the right answer or not. So how was this? Did you get it, or what happened? What happened with this question? Anyone? Can I know what happened? Okay, let me check the chat box. Happy, got it. Very good. Because these are the hard type of questions. You know, friction questions can be made hard because there are all these conditions that they can impose on a scenario. So great, Kavindi. Great. I'm happy. Others? Good, Mihir. Did everyone get it? So I'm waiting. Each one of you has to tell me, drop a message. Who else is here? Umalia. Umalia, did you do it?
Good afternoon, Miss.
Good afternoon, Nathan. Umalia, okay means you got these answers, part 1, part 2 answers, the condition, the inequality for mu. Do you have any doubts or any unclear parts?
Miss?
Yes, Nathan.
I tried the question, but I seem to be stuck.
Okay. Both parts or?
Yeah, I somehow tried and got up. Was this I got mu for the first one? I got mu equals 0.953. That is greater than 17 over 24.
You didn't get that.
The first part.
You didn't get that. You didn't get the first
I
part?
got the answer for the first part.
You got the first part.
No, I got the Miss. I got the first part, but I'm not sure it's correct.
What's that?
Yes, Miss.
You got the first part. Did you get the inequality?
I got the first part. Can you?
Okay.
Yeah, I got it as 0.953.
What is 0.953? Did you get 17 upon 24?
No. I didn't get that.
You get that. Okay, so you didn't get the first part. Okay, let's quickly discuss this. Who else? Joanne, did you get this question number 16? Number 16? Joanne? Okay, without wasting time, waiting for your responses, I will quickly discuss it then anyway. Then others also can maybe benefit from it. You can check whether your approach was right. So it says, I will draw this first diagram, number 16. So you have a slope, angle is alpha. You have a block kept on the slope. Weight is 7.5. I'm going to mark everything on this diagram itself. 7.5. Okay, they have given that tan alpha. So this I will write on the side. Tan alpha is given to be 7 upon 24. Now you know what to do with this. This is not the first time we are coming across this. The moment they give you not directly the angle alpha, but a trigonometric ratio of alpha, you put it into a right angle triangle. Hatfi, this has a connection to the question you had asked me yesterday. If you have one of the ratios of an angle, sine or cos or tan.
Understand.
Okay, you can put that. Nathan, can you mute? You can put those numbers. Now this is a fraction. You know that tan of an angle is, so if this is the alpha angle in my right angle triangle, if tan alpha is 7 upon 24, since tan is opposite over adjacent, I can put 7 for opposite side and 24 for adjacent side. So the ratio between these two sides is 7 divided by 24. So that these two numbers would fit as the lengths of a right angle triangle whose angle here is alpha. Then when you have that, you can find all other ratios that you want. You can find sine alpha, you can find cos alpha, you can, if you want the reciprocal ratios, you can find, right? You only need the three sides. So when you have these two, you can find the hypotenuse. I think it's 25. But how can't, but how can't, how can we say that, alpha is an acute angle? This is a slope. This is a slope. Alpha is an acute angle. You can't have a slope like that with an obtuse angle. This is an inclined plane. It is implied that alpha is an acute angle. But if something like that comes in a P1, P3 or P1 paper, they will tell you that alpha is, if they just say tan alpha is this, they have to say that alpha is an acute angle for you to put it into a right angle triangle. But in this, that extra information need not be given, because this is the angle made by an inclined plane. An inclined plane means it's an acute angle. You cannot have an inclined plane in any other way, right? Great. So this information, you immediately have to put it into a right angle triangle and figure out the hypotenuse. Is it 25? Can someone quickly verify this? And then you write sine alpha and cos alpha, because those are what you are going to be needing in this question. We are not going to be needing tan alpha. You know, when you resolve your weight into components, you're going to be needing cos alpha and sine alpha, right? So you keep them ready here to be applied. It's 25. Thank you. So sine alpha is 7 over 25, and cos alpha, all this is happening on the side. This is side work. You will need this later in your proper mechanics work, when you apply the physics or the mechanics part. Okay, cos alpha is 24 upon 25. Okay, so we'll keep that ready here. When we need those, we can take it from there. What else then we have? So a block of weight is at rest. Now I know the motion of this object, it is at rest. Let me just note it down. So if I don't mark with an arrow in my diagram, indicating that it is accelerating or moving at a constant speed, you remember how to mark it. If your block is accelerating either up the slope or down the slope, you would mark with an arrow alongside the block with a double arrow line. If it is accelerating, if it is just moving at a constant speed, you would mark it with a single arrowed line. But if you don't put anything, that means it's at rest. But just to make sure, let me say it's at rest. We know it's at rest. And here I am applying Newton's first law. At rest means equilibrium, forces are balanced. Capital F is 0. Resultant force is 0. Okay. So let me note it down. Is at rest on a plane which is inclined to the horizontal angle. The coefficient of friction is mu, so it's given. Mu is mu, right? We can take it as mu. A force of magnitude 7.2 acting parallel to the line of greatest slope. So 7.2 is acting that way. 7.2. When the force acts up the plane, the block remains at rest. Did they already not say it is at rest? Why are they saying it again? A block of weight is at rest on a plane. That means even without this, it was at rest, right? A block of weight is at rest on a plane. And then a force of magnitude 7.2 acting parallel to a line of is applied to the block. When you apply this, still it is at rest. Okay, still it is at rest. When the force, the block remains at rest. Is that clear? So now let's mark the rest of the forces. What other forces are acting on this? You would have reaction force, the normal reaction R, and you're going to have friction. How do you know the direction of friction? How do you know the direction of friction? And also, is it going to be F max or something smaller than F max? So the answers to these two questions have to be really clear to you. Without that, you can't proceed. Now, you know you have to mark friction. My question is, in what direction does it act? And is it F max?
It's I think it's yeah, F max. I think so. F max.
Why do you say it's F max?
Uh,
So this is the thing, you have to be thorough with the theory to answer these questions. Maximum friction acts, either you have reached the limiting equilibrium, if you have reached the point that it is about to move, or if it is moving now, if it has started moving. If something is moving, maximum friction would be acting on it, or it is about to move and still in equilibrium. These two are the two cases in which maximum friction acts. If now this is not moving, it's at rest. And do they say it is limiting equilibrium? Do they say it's about to move, or that it is in the limiting equilibrium? Do you see those words anywhere? No. So there is friction acting, but it is not the maximum friction. So that's one thing. We figured that out. In what direction does it act? I will help you to answer that question. Even before you apply this 7.2, it was at rest. The first sentence says a block of weight 7.5 is at rest on a plane. So without this, for a moment now, imagine before you applied this 7.2 Newton's force, still it would be at rest, which means friction would be acting. In that case, without 7.2, it would be acting. Good, Kavinda, I think you are answering my previous question. That is, in what direction it is acting? It is down, you're right. Without 7.2, it will be acting upward. Good, Hatfi. Without this, it will be acting upward. How do we know all this now? Tell me. Without the 7.2, remember, friction acts to stop the object from moving. Friction tries to stop the motion. So without the 7.2, when you keep something on a slope, it tries to slide down. So friction will act upwards. That is without this. So even without this, friction is large enough to keep it from moving, right? But now we have applied an additional force upwards. So now it must be trying to move up. So friction will have to act downwards. Friction has to, it can't still be acting upwards, because while it was acting upwards, you came and you started to apply an additional force upwards. Immediately, friction will start acting down to prevent it from moving up. Okay, so there is friction acting downwards, and it is not F max. Why? Because it's not moving, and it is not in a limiting equilibrium point, the point of limiting equilibrium. So this is just F. So I can immediately say, something I'm immediately able to say is that this F that I have marked here is less than F max. Less than or equal to. Let's put the equal to as well. Less than or equal to. F max, it's less than or equal to maximum friction. Okay, then you can start applying your laws and formulas. This is in equilibrium. You can apply vertical equilibrium and horizontal equilibrium. Vertical equilibrium and horizontal equilibrium. So if you apply vertical equilibrium first, vertical equilibrium, if you apply vertical equilibrium, R is equal to 7.5. Let me mark it here, 7.5. This is alpha. So 7.5 cos alpha, that is R is equal to 7.5 times cos alpha. I need it from here, 24 over 25. No need to simplify. Let's leave it like that. Then vertical equilibrium, I can even put like double arrow like that in that direction. Sorry, horizontal equilibrium, what do I have? 7.2 upwards is equal to F plus 7.5 sine alpha, 7.5 sine alpha. Right? Now, so this is part 1. It's clear that I have to use this condition to get that inequality, because it's an inequality. This is the only place where I have some inequality condition. The friction acting in my scenario is less than the greatest friction that can act between these two surfaces. Shall we find F max? What's the maximum friction that can act? That is not the force that is acting here. But what is F max? Let me find F max just somewhere here in a little bubble. I'm finding F max. What is F max? F max is mu r. That is mu times, what is r? R is here, 7 times, mu times 7.5 times 24 over 25. Okay, that's what F max is. Now I'm going to use this inequality. I'm going to apply everything into this inequality. I'm going to use this again. I can find F from this equation, and then I can put it here, and this F max, I can put it here. I'm going to get an inequality in terms of mu. Now you have to see this, okay? So I'm going to use this F max and this F and put that in this inequality. So let me make F the subject here itself. F is equal to 7.2 minus 7.5 times sine alpha is 7 over 25. This is F. This is F max. Now, if I use this inequality now again, I know that F is less than or equal to F max. So F is this. I mean, I don't need to do everything now. You can do the simplification. 7 over 25 is less than or equal to F max, which is this, mu times 7.5 times 24 over 25. Do the simplification, make mu the subject, and you should get that answer. Mali, this I came now. I'm sorry, I had been logged to your Hiyo. Malit, yeah, Malit, I know. This is something that can happen to you, not to anyone else in this class. Uh, I'm sorry that I said it out loud. Uh, anyway, Malit, we were just discussing number 16, the homework in the book, the textbook question. I know, I'm just joking. Okay. Right. So this is part 1. So you can continue this. Nathan, you can try from this point onwards. I want you to somehow do it. I hate showing you. This is how you do it, step by step. That is not productive. That's not useful to you. If you can spend even one whole day struggling with the question and somehow get it, That's what is productive, and that's when you would learn and build that confidence that would help you in the next question. Okay. Try to complete the rest of it and get the inequality. And in part two, now you should be able to do part two. They say when the force acts down the plane, the block slides downwards. Okay. So try to think through that on your own. So I helped you in part one. If there is anyone who couldn't do part two, try it again. Okay. So I'm going to leave part two again for you. Please try to do it. Part two. Okay. Then the next question was from the worksheet. This question number 5, this one, and number 6 on the other page. How was this number 5? How was this? I know that I didn't give you like answers to check, but what is the answer you got? What are they asking? The greatest possible value of P is twice the least possible value of P. Find the value of the coefficient of friction between the particle and the plane. What did you get? Kavindi got, okay, Kavindi got 1.7. So this is question number 5 in the worksheet. Kavindi got 1.7.
Miss,
Yes.
I got 0.577.
Nathan got 0.557. 557. Any other?
No, sorry, Miss. 577.
Any other answers? I need to talk to you. Hatfi says 34 upon 21. Is it same as one of the others? As my calculator. Do you have your calculator? Can you check whether it is similar to one of these? It can be 1 point.
Similar to 1.7.
It's same as 1.7?
Yeah.
It's 1.7. Okay. So 1.7 seems to be correct. Let's see where Nathan went wrong. I want to hear from each one of you. Now, not everyone is responding. This is the thing. Can you, who else? Hi, Bimandi, you are here today. Bimandi, did you get this? Joanne? Umalia? You need to hurry up and tell me. Mihil, 1.6. 1.6. Close to 1.7, no? But it's not 1.6, it's 1.7. Should I like start it maybe and show you then? Okay. Let me keep the question like that. A particle of, this is question number 5. A particle of mass 20 kg is on a rough plane inclined at an angle 60. Particle, I'll draw it like that. 20 kg, I can immediately mark 200 newtons. The weight, reaction, 60 here. Oops. Got blurred, no? Right. Equilibrium is maintained by a force of magnitude P acting on the particle in a direction parallel to the line of greatest slope of the plane. Now, they don't say the direction of that force. Yeah. So they say equilibrium is maintained. Now, you know, by the application of this external force, you can keep, this is exactly what we discussed last week. This, uh, to keep it, from moving, you can apply a force up the slope, but this P can take a range of values. You can apply some from a smallest possible value to a largest possible value, and any value in between. With any of those values of P, this can be kept in equilibrium. This is exactly what we did last week. The greatest possible value of P is twice right. Okay, so P max is equal to 2 times twice the least, 2 times P min, right? This is this information. The greatest possible value of P, that is P max, is twice the least possible value of P. Find the value of the coefficient of friction. Okay. Right, in this diagram I'll draw F. So it depends, right? If it is P max, it will be in one direction. When it is P min, it will be in another direction. F max will be in another direction. How do I show it? I can't show it. So what is P max? I'm going to just use this formula, like a formula. What is P max? P max I can write as, I know P max is, I get P max when friction is acting downwards. So P max is a component of the weight 200 sine 60 plus F max, right? That's what P max is equal to 2 times, what is P min? Minimum P is when F max is acting towards P, then P min is component of the weight 200 sine 60 minus F max. Is this right? Is this right? So let me show you last week's note. Okay, I hope you remember this. I hope you remember all this. Okay. So I straight away used these two formulas. Okay. And now they're asking for mu, right? This is at rest. So you can apply, now I will remove that. You can apply vertical equilibrium. If you apply vertical equilibrium, you get R is equal to 200 cos 60. Why am I finding this? I need R to write F max. That's why. So 200 cos 60 is 100. R is 100. Okay. Then I would use this R here. 200 sine 60 is 200 root 3 over 2. Root 3 over 2. Plus F max is mu R, mu times 100, equals 2 times 200 sine 60. Oh, it's the same thing again. Minus 100 mu. Right? You solve for mu here. Am I right? Nathan, where is your mistake? Nathan?
I have done correctly so far, but after only I have done the biggest mistake. That means I, instead of leaving them as exactly the way they are, I turn them into decimals.
So how many times have I told you that even if you turn it into decimals, you should get the answer now. if you turn this into decimals, you are not going to get the exact answer. You will be off by some little amount. Your answer won't be as accurate as, I mean, if you do, as long as you keep irrational numbers in this form, you will get the exact answer. If you use decimal form, you will go a bit off, but you should get something close to 1.7. This is nowhere close to 1.7, your answer. So there must be a greater mistake than that. Did you get this step? Have you written this?
Okay, I took them as two different equations. Not like I didn't take P max equals to P min. I just took like this way. P max equals 200 sine 60 plus
F max.
Yeah, plus F max. Then after I took P min
right,
divided by 2 equals that thing. So basically, if I do it that way,
P min, wait. P min divided by 2 is equal to P max?
no. So P max divided by 2 equals P min.
Yeah, so if you use that relationship.
Yeah, so I got it so far. After that only I simplified
okay, so you have to check. You have to check then. Looks like you're on the right path as well. And then you just have to make mu the subject. So from this point onwards, it's just algebra. It's just math. This is where you apply your friction knowledge and equilibrium knowledge, all that, all forces and mechanics knowledge. From this point onwards, it's pure mathematics. It's not applied mathematics. It's not mechanics. It's pure math. It's like P1 or P3 from this point onwards. Okay. So solving this is up to you. Then, if that is okay, your last homework was question number 6. This one. Malit, Nathan, your answer was 0.5. Yes, Malit, 0.57. Why? Oh, it's correct.
Yeah.
Very nice. Very nice. Now, how many of you got 1.7?
Yes. My God, I got shocked. I was scared.
So, how many of you got 0.57? According to your... Hatvi got 1.62. Okay, shall we continue this and see then? I have to find my... I'm very happy to hear that, Nathan. You are right. Let's see. Let's do this. I'm going to continue this. Thank you, Malik. Yes, I'm going to continue this. I'm going to multiply this whole equation by... no, I'm not, because this 2 gets cancelled. 100, and then I will put this in. Okay. 100 root 3. 100 root 3. This is 100 root 3 plus 100 mu is equal to... I'm going to remove this bracket. 200 root 3 minus 200 mu. Mu on one side, 300 mu is equal to 200 root 3 minus 100 root 3. I will divide everything by 100. I can cancel off the zeros. So it's just... Oh, I'm sorry. I divided the whole equation by 100. Then I get 3 mu is equal to 2 root 3 minus root 3 is just 1 root 3. And mu is root 3 over 3. Is that 0.57? So this is 1 over root 3. Is that 0.57? Shall I get my calculator?
Yes.
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 Great.
Maybe I am.
I'm happy. It is. Now others, those who got 1 point, because couple of you had gotten the same wrong answer then, 1.7. How was that? Can you all check your... Hatfi, where is your mistake? Hatvi, and also was it who else got 1.7? Kavindi also got 1.7. Hatvi and Kavindi, did you find your mistake? Hello, Kavindi and Hatvi. Yeah, okay. Hatvi thinks it's a simplification error. Okay, so please check your work and find out where you have gone wrong. I would be happy if your concept is right and you made a mistake in the, like Hatvi said, in the simplification. That is something that can be corrected, but if you be careful. But if you have made a conceptual mistake, if you were not able to, for example, write Pmax and Pmin and build the connection that they had given you, that if you have made a mistake in that part, that would be something to worry, and you have to work on that then. Okay, so that's number 5. Then number 6. Show that the least possible value of P is this. So there is a show part. Did you get that in number 6? And then find the greatest possible value of P.
The answer. Okay. Let us find P min and P max, no teacher?
That's correct. Least possible value. So
Okay.
P min, you find P min, and it has to be 0.394. Did you
Yes,
get
I
that?
got the answer. I got it.
Good. Others?
P max 20.1.
And how much is P max?
20.1.
Can you give me a moment to get a pencil? I have a pencil, but it's not sharpened. What's the P here? No,
P max is 20.1.
0.57. How much?
P max was 20.1.
20.1.
Yeah,
Is that right?
I hope so.
Kavindi, good, same. One more person? One more person, P max? Okay, Umalya. Okay, so looks like it's good. Now we have 2 options. Ideally I would like us to complete all this. So there are 1, 2, 3, 4 more questions in under friction in this worksheet. I would like us to complete that before we start the next topic, which is connected particles. So one option is to actually do this in class right now. I let you do it and we discuss it, or I can give all of them for homework, but I would like to do it now because I want to see how when I give you for homework, I'm not sure whether, not that I don't trust you, but I'll tell you. Shall we do at least 2 of these questions now?
Okay.
Okay. How is your confidence level in terms of the topic friction? How do you feel? Do you feel like I can tackle any friction related problem, or is it a bit shaky?
It's okay. Yeah, it's okay.
Okay. Shall we try this number 7?
Yes.
No positive about friction. What? Yes, positive about friction, Malit. Did you put no when you meant to say yes? That's going to be a big problem. Okay. if you get mixed up between yes and no, like I get mixed up between left and right and push and pull, if you get mixed up between say yes and no, then you are going to end up with a big problem. Okay, number 7. Yes.
Miss, aren't we going to do the sixth one?
We did six. What? Sixth is what you did for homework. Now number 7.
Yeah, I know.
Yeah, we are not going to do this because you all
Ah,
got
well,
the answer.
okay. Okay then. Then okay. Okay.
Right?
I thought
Is there
And
anyone who wants
he meant discussing it.
yeah, discussing.
Do you want me to discuss this? If all of
No,
you
no, no,
got the
no,
answer.
no, no, no. It's okay.
Number 7. Start. So no diagram given. You have to draw up sketch a diagram. A particle of mass 0.2 kg is resting in equilibrium. In equilibrium, make a note of in equilibrium on a rough plane inclined at 20 degrees to the horizontal. Show that the friction force acting in the particle is this. Correctly? Okay. It's just 1 mark. So I hope you have finished sketching the diagram by now. So I will slowly start drawing it too. Let me do it like this.
Please give me a second. I'm still writing down the question.
Ah, right, okay. Oh, you're copying the question. Okay. Can I start drawing?
Okay, Miss, done.
Okay. The only reason why I am showing you how I draw my diagram is I'm modeling you. You have to learn by watching, right? Like how I do it. So as usual, the first thing I do is mark the forces. It's resting in equilibrium on a rough plane by itself. No external force is applied on it. When you keep it it is resting in equilibrium. In what direction is friction then? Is it just some friction or maximum friction? Do I mark
Maximum
it?
friction.
Why do you how do you know it's maximum friction?
Because miss, if it is maximum friction, now it doesn't have equilibrium now, miss.
Yeah.
So for to stop a particle from moving and keeping it at one position, the friction has to be at its maximum. Or else if it is at the point where it's going to move, then it should be either it should be the F that means friction should be minimum, or that means or the force must be greater than that.
What? What? Can you repeat? So if you get this point wrong, everything falls apart. If you can't confidently figure out whether the friction acting in a certain scenario is the maximum friction or not, maximum friction or something below that, if you can't figure that out, everything else falls apart in friction problems. I will let you rethink. Now, for example, here's a slope. Here's an object. Here's a slope. I keep the object on the slope. It's not it's resting in equilibrium. So there is friction acting upwards. Is it maximum friction or not? How do you know? So if I change the, I hope you can see, I'm changing the inclination. Still it's resting in equilibrium. If I change now a small theta angle, there is friction acting upwards. It's resting in equilibrium. I am tilting it further up now. What can you say about the friction acting now compared to the friction acting like that? Greater. Now the friction acting is greater than the friction acting like this. What can you say about that friction? Is it the maximum friction? Is it the maximum friction now? Did you see it started to move at a certain angle? If I were able to stop right at that moment, just when it was about to move down, that's the maximum friction. At any other angle less than that, it's just some friction. Remember how the friction increases to counterbalance the force trying to move it, which is the component of the weight. Please go through the note again. We spent a lot of time discussing that on the first day, not last week, the week before. How the size of friction changes as the force trying to move the object changes. If you think of an object on horizontal ground, like this table here, okay, I am pushing it now, but it's not moving. I'm pushing it with 5 newtons. It's not moving means there is 5 newtons acting in the other direction, friction, 5 newtons. I push it a bit harder. Now it's 7 newtons. Still it's not moving. That's because the friction has increased to 7. It's not reached maximum. So friction will keep increasing, counterbalancing the force that I am applying in trying to move it. How far can it increase like that? Up to a certain value, what we call the maximum friction. When that reaches, say the maximum friction that can act between this table and the floor is 10, then I can, until I apply 10 newtons on this, it will not move. When I apply 5, friction is 5. When I apply 6, friction is 6. When I apply 7, friction is 7, 8, 8, 9, 9, 10. When I apply 10, friction would now it's trying its best. That's 10. And now when if I'm pushing it at 10, friction is also 10, and now it's about to move. Why? If I increase my force by tiny bit, friction can't increase anymore, and it will start to move. That is the limiting equilibrium. When you see the word equilibrium, don't think it's F max. If it is limiting equilibrium, meaning it's about to move, that's when maximum friction acts. And also after that point, now 10.1, if I do, it will start moving. And if the object is moving, friction is the maximum friction. I mean, after that, it's just Malik has finished it while I was explaining. Okay, anyway, so this is not the maximum friction. It's just resting in equilibrium. So some friction. The size of that would be such that it is only to counterbalance the component of the weight that is trying to pull it down. Just enough to balance it. If that component is 5, friction would be 5. We would know that it is the maximum friction if they had said that it is in limiting equilibrium, or if they had said it is about to slide down. They didn't say that, so it's just F. It's just F. How is it maximum friction? Now I spent again another chunk of time explaining that. So please, you have to spend now time on your own, going over the note and thinking about this properly, reflecting on it properly, and digesting it properly, and putting it into your system. Now this must not happen again. Okay, Malik. Right? So it's just F, not F max. Just some F less than F max. And then F is equal to 2. This is 20. F is equal to, this is horizontal equilibrium. Horizontal equilibrium. F is equal to, you don't find this using mu r because it is not F max. It's just friction, some friction. So that is equal to, it's in equilibrium. So upward force must be equal the downward force, that is 2 sine 20. So you have to get 0.684 there. See, so I was right about suggesting that we should do this in class while discussing, because I have to be convinced that you have gotten this properly. Okay, next part. The coefficient of friction between the particle and the plane is point. Now only they are giving mu. And that's an indication that we don't need mu in this. That's an indication that this is not F max. The coefficient of friction is 0.6. A force of magnitude 0.9 is applied to the particle down a line of greater slope of the plane. The particle accelerates down the plane. Find acceleration. Can you do it on your own? So Malik has gotten an answer. I don't know whether that is right. So if friction worked the way Nathan told, object would just roll down a slope once it's placed right. How did Nathan say it? Which is why it's wrong. How did Nathan say about friction? I didn't understand.
You don't want to know this.
Malik, can you?
No, miss, the way I got the way I got what Nathan said was that like he said, since the object is stationary, then it's in equilibrium,
Yeah.
and then in order to keep it in equilibrium, you have to provide a maximum force.
Why
and
is
then,
that? No,
Yeah,
right. Yeah.
that's what I wanted to know.
Yeah. So
Because I start at one point, I also started to believe in it, and then I went back and
realized.
yeah.
Right. So if the object is not moving, if the object is at rest, it means the friction is not at its max. We don't know that. It means friction is balancing the downward force, whatever that is, which is a component of the weight. If this is at rest, the forces are balanced. That's all. So whatever the friction acting is balancing the force down, the other force downwards, and the reaction force is balanced by the vertical component of the weight. Friction balances the component of the weight. It is not the maximum. It could be. It could be the maximum if that would be when it is in limiting equilibrium. Okay. So acceleration, how much is that? No one. So we all, Nathan, it's fine. It's fine. Yeah, it's fine to try and correct each other. You correct me all the time, right? Yeah. So that's a good thing. Okay. Yeah. Right. So A. What's A? And what's the diagram for the next part? Now it should be a different diagram for the next part. Shh. For the next part, so I will keep this like that. Let me start here. Right. So what's happening now? You have the same slopes. The slope didn't change. So angle is the same. 20 degrees. The object is the same. Its mass didn't change. So weight is the same. 20 is still acting downwards. Not 20, just 2. Sorry. Just 2. A force of magnitude 0.9 is applied to the particle down. Now R is there. You are applying, sorry, I will mark it here. You are applying a force down. 0.9 newtons. And it is accelerating down. Now notice where I mark the motion arrow. Motion arrow. Okay. It's not a force arrow. How do we know? Because it's not passing through the object. It's outside of the object. That is to indicate it's moving. And double arrows to say it is accelerating. It's accelerating downwards. So now, in what direction friction acts, and is it maximum friction? Can Nathan answer? It is moving down now, and there is an additional external force also. What matters, what you need to know is whether it's moving, it's accelerating downwards. What's the direction of friction, and is it F max or not?
Friction is acting upwards. That would mean F max is no. I'm just scared whether my answer might be wrong.
Take your time and think and answer. No need to rush. It's moving, Nathan. It's moving.
It's going downwards, so it's already at F max. Yes.
It's F max. If it is moving F max, no second thoughts. After it has started to move, then this maximum friction sustains. Very good, Hatvi. Yes, Hatvi is right too. It's maximum friction. If it is moving, maximum friction. Right. So those are the forces, and you have to find A. F equals ma. So this way it is in equilibrium, vertical it is in equilibrium, vertical it is in equilibrium. So R is equal to 2, we found it earlier, I think, 2 cos 20. And then this way it is not in equilibrium, it is moving. So you can apply F equals ma downwards. It's a vector equation. If you don't have this arrow put, your working is not good. Then you can't just write F equals ma without saying in what direction you are applying F equals ma. It's a vector equation, just like equations of motion. So it's downwards F equals ma. Resultant force this way, the resultant force this way is 0.9 minus, sorry, 0.9 plus, let me add the component of the weight, plus 2 sine 20 and then minus F max is equal to, mass is how much? Mass is 0.2 A. F max you can put mu r. So this is 0.9 plus 2 sine 20 minus mu is how much? 0.6 and r is 2 cos 20 equals 0.2 A. You solve for A. What's A? Kavindi got 2.27. Is that the same thing?
Yeah.
Good, Kavindi. And Malik got that too. Let's
Yeah, miss, instead of 2.27, I got 2.28. Ooh, that's not good. That's not good.
It's fine. It's fine. I'm thinking where you. So did you? I mean, do not make any approximations on your way. Take everything completely till the end. Now this, do you notice that I don't, now this 2 sine 20, I didn't find the value of that there. I am keeping it as it is, right? Even when I solve for A here, I would keep writing it. And in the last step only, I will input into the calculator to get the answer, so that I'm not making any round approximations on the way. Intermediate approximations are not done.
Yeah. Are you sure it's 2.27? Because it's
So
2.
I will tell you what A is. A is,
Yeah.
how you would write it is this:
She
0.9
rounded off.
plus 2 sine 20 minus 0.6 times 2 cos 20, the whole thing divided by 0.2. If you can input this into your calculator carefully by the use of
Yes.
proper brackets, you will get the exact answer without any. So is it 2.27 then?
No, it's 2.28.
Is it
That's the correct.
2.28?
Yes.
So again, it's Nathan who is correct.
Malit,
Of
actually.
course,
Malit.
okay, Hatfi saying too, it's 2.28. Thank you, Nathan and Hatfi. It's 2.28 meters per second squared. Of course, we'll do another one. See, do you feel that the more the more questions you do, you cover all sorts of different types in which these problems can come, and you get better at solving them. So that's why I want to, as I have told you this in before, in mechanics, theory is little, you have to practice a lot. Okay, so most of the time has to be spent in solving problems. Number 8, do number 8 as well. Let's try to finish this worksheet today. Then we can start connected particles as a fresh topic next week. Number 8. Start, you draw a diagram again. Diagram is not given. Number 8. A particle is released from rest and slides down a line of greatest slope of a rough plane, which is inclined at 25 to the 25 degrees to the horizontal. Mu is 0.4. Find the acceleration of the particle. Can we have a diagram for this? Do you have the diagram ready? So in this scenario, when you keep the particle on the plane, just as you keep it, it starts to slide. So friction. So I would not say anything about friction. There is a frantic ant who's frantically moving on the in a zigzag Brownian motion, like we saw the other day too. You see? Okay. I hope you have completed the diagram. So I will sketch a diagram for number 8. I too will sketch a diagram for number 8. $25 object. Notice that the mass is not given. Mass is not given. You let the mass be m and mark the weight as mg. Simple. Or 10m. We take g to be 10. So you can say 10m. Okay. So that means you have assumed the mass to be m. You can predict that we are not going to be needing mass to get this answer. M will get cancelled at some point. That's why they haven't given it. It's accelerating downwards. What direction is friction, and is it F max?
It's acting upwards and it's F max.
Very good, Nathan. Very good. So it's moving, it's accelerating downwards. Vertically, you can apply equilibrium. It's in vertical equilibrium. Vertically, it's not moving anywhere. So vertically, the forces are balanced. So you apply vertical equilibrium. You get R is equal to mg cos 25. You leave it like that. And then this way, F equals ma. We have mg sine 25 minus F max is equal to MA. We don't know M, we don't know A. Mg sine 25 minus mu is given. So for F max, you can put mu R, mu is 0.4, R you can put from here, mg cos 25 equals ma. Do you see m gets cancelled? Divide the whole equation by m. Each term has m in it. Now solve for a. What do you get? Your friend is here. Your little friend. Uta,
Miss, three significant figures.
wanna say hi to these Ayalas? Huh? What's that? What's that, Nathan?
Three significant figures.
What's that? How much?
Three significant figures, right? For A?
No, find the acceleration of the particle. Just it must be a good answer, I think.
Okay. I found it.
Hi. Will you all say hi to him?
Hi.
Okay. You can just say hi to them, isn't it? Yeah?
Is Tarindu no, Miss?
It is Tarindu. Tarindu is not here today.
Tarindu. Hello.
Oh, his name is Pramindu.
Pramidu. Okay.
.6. Is it 0.6? Is the
Yes.
acceleration?
I wrote 0.601.
Or is it exactly 0.6?
There's a certain decimal thing, but I wrote it under three significant figures.
Because they are not saying
Yeah.
0.600, so 0.6 is good. Okay.
Okay.
Part 2, find the distance traveled by the particle in the first 3 seconds after it's released. So this is to do
First
with
3 seconds.
equations of motion.
Oh.
Part 2 is about having to find distance.
S equals ut plus half at square.
Write a list of information that you know. You know A, what you found. You know U is 0. You know time is 3 seconds. 3, you have to find S.
Found it.
So that answer to 3SF you have to give.
Yes.
It doesn't say, it doesn't say. Find the distance. So when not stated, you have to give the answer to 3SF.
Found it. May I say the answer?
Yes.
The answer is 2.7.
Correct, everyone?
Yeah, Miss, for acceleration, I took my answer, not the 0.6. I took 0.601. so it gives much more accurate answer. I just took that way. That's okay, no?
Yeah, that's a
Yeah.
correct. No? Okay. So 2.7. Now it's only the same people are responding. Hatfi, Malit, and Nathan. I rarely hear others. Mihil every now and then. Okay, Joanne, thank you. 2.7. So please drop like a small. I don't know whether it is hard for you to like. Does it disturb you when you have to type in a response while working? I don't know whether that's why you don't do that. Okay, if not, please like just uh, uh, talk to me. Okay, right. uh, Number 9, and then number 10, maybe I will give you homework, and then we can start connected particles next week. Number 9, shall we quickly try to do number 9 also? Here's your number 9 diagram given. 6 marks, just one question and 6 marks. Again, it's similar to the earlier one. Show that the least possible value of P is this. Remember, number 6 was similar. And then find the greatest possible value for P. So this is about max, P max and P mean. This is the external force that you are applying, the maximum external force and the minimum external force that you can apply to keep the object at rest in equilibrium. Oops, sorry. So can you start that, number 9? And let me completely leave you with it. Okay, leave you with it means I will not say, but this will build your confidence. If you do this on your own, that will boost your confidence. And that's exactly what I need to happen. So I will keep quiet, leave you with it for my like 5 minutes. Okay, just quietly work on it. First part is a show part here, so you know when you get it right.
Done.
Okay. Okay, so Kavindi has also gotten P max. Okay, Hatvi done too. Can you all drop a message with your P max? Okay, Malit, creative. What's your P max? Yes, correct. Good. I am very happy. I will tell now you if you can find out. This is a type of question that students find hard, especially related to this PMAX and PMIN. They students find this kind of questions hard. Oh, Malik got a different answer. No, yeah, Joanne, correct. Yes, 3.83 is correct. Malik, did you get the P min correctly? 0.47. Okay, then how did you go wrong in the other one? Hatfi, what did you get? Mihir? Yes, Hatvi. Okay. Now, if some of you are still working on it, don't be pressurized because we are like talking about being done with the question. It's as I always tell you, uh, you don't have to do it quickly. You have to do it correctly. Take your time. It's fine taking your time. The speed is something that we only need for the exam. Speed has nothing to do with your ability in mathematics. So if I am waiting for a small message from Malik got it too. So far Kavindi, Joanne, Hatfi, Nathan, Malik, 5 of you got it. Okay, Bimandi got it. Mihil and Umalya?
Miss, my mistake was, Miss, I thought that P can only be in one direction just because I put it on the diagram. I thought P is like only upwards and doesn't go down. That's where I got wrong.
Okay. But I think P is upward, isn't it? Isn't it? P is always upward. It's the direction of friction that changes.
So then 2.15 is correct now.
Okay, let's read this. The particle is kept in equilibrium by a force of P acting parallel to the line of greater slope of the plane, as shown in the diagram. The coefficient of friction, yeah. Mihil got it too. Okay, Umalya, you haven't gotten. Umalya got. Okay, now. Okay. So, did you have to put P in the other direction? Down the slope?
No.
No, it is upwards. P is upwards. When it is P max, friction would be downwards. When it is P min, friction would be upwards. It's the direction of friction that is different in the two cases.
Okay, Miss. It's okay. I got it.
Got it?
Careless mistake.
Okay. So, this is good. I mean, you did that on your own, means it's good. It's 6 marks. Okay. And this 10th question, I will just show you the only difference. Now, this is difficult. 8 marks. Why is this more difficult? That external force applied is not parallel to the slope. It's at an angle. So it'll have two components, one parallel to the slope and one vertical to the slope. So that changes the dynamics a little bit, but I mean, the theory that you know, all that is the same. So that's a new scenario that you have not seen before. So I will leave that for homework. I will send you a picture of that for homework.
Miss,
8 marks.
can I just ask?
Yes,
Oh,
Mike.
sorry, miss. I'm sorry. I'm sorry.
What?
You continue. I'll say no, it was not